All right. Good times. Good evening. Oh, it's nice to have working headphones again. Let me just get set up. It's been a bit of a crazy day. That's a bit better. All right, so what day is it today? Tuesday. On Thursday of last week, I was working through the advanced React hooks. I think we were on custom hooks. Yes, we were. And I just returned this, so that's cool. Make safe dispatch, which I'm pretty sure is the extra credit. Yeah. So this was I'm pretty sure I said this one's difficult, intentionally vague. This one's a bit tricky, yeah. Okay, so the gist of it, I'm pretty sure. Let me just get my code up. I'm pretty sure we need to cancel the promise. What happens if the component unmounts before this promise has completed? So we're basically looking for a way to abort the promise. We can use this checkbox to control the component mounting and unmounting. We'll get a memory leak because dispatch will be called on an unmounted component. The best solution to this problem would be to cancel the request, which I'm pretty sure is the fetch abort controller. Yeah, that's cool. But even then, we'd have to handle the error and prevent the dispatch from being called. So, see whether you can work out a solution for preventing dispatch from being called if the component is unmounted. Depending on how you implement this, you might need useref, use callback, and use effect. So, at the end of Thursday, I implemented a terrible abort mechanic, which I'm pretty sure you didn't need it here. I think it was in the actual app. Yeah, so we had a piece of state here. This would return on unmount when it cleans up. It would set this to true. I was basically trying to emulate component will unmount. And I passed that through to the Pokemon info. Well, Pokemon info. I then passed the abort into the use async hook. If abort is false, then commit the promise. So I asked about this on Kent's Discord, and I'm pretty sure you can't cancel this promise. But the first thing I'm going to do is take this abort out because I am 99% sure it's not the correct implementation. So let's take out abort. I'm gonna remove this from here. Not gonna pass it through here. And let's take this out. Cool, so we should now have a working version of this. It's cool. Just make sure there's no errors. Cool. If you want to move on to this last credit, copy pasting the solution to the previous extra credit before, otherwise you'll probably have a hard time iterating your solution. Yeah, that's fair. I actually thought this was pretty close to the previous iteration, but I will do that. Where could I find the solution to the extra credit? Yep. Yeah, I need to. I actually only have one monitor just now. I'm really tempted to get a second monitor to have the chat on screen. And the final directory. Yeah, cool. Okay, so we are on exercise 2 and extra credit 2. Nice one. Thank you, Kent. All right, so I need to abort the promise. First thing I'm going to do is how to cancel promise. Yeah, so this is what someone said on your Discord. Promises can't be cancelled. It's the process that returns the promise that must be cancelled. Okay, so we have this run function. Is there any way we can cancel this? I could really do it with a little koala helper for this one. So you said that the best solution for this would be to cancel the request with the abort controller, which is what I originally thought to do. But from the way you've worded it, it sounds like we shouldn't be using this. I wonder why. Yes. Yeah, and that makes sense, right? So I don't know how earlier on, how long you've been in the stream, but previously in this app, I had a piece of state that said should it abort, and a use effect that was empty, So it would run on the return, it would run, I was basically trying to emulate component will unmount. And when that ran, I would set that piece of state to true, pass it through here, and pass it all the way through here. And if abort was true, then don't run this. But the promise can't be cancelled. Ah, it's the dispatch. Yes, cool. Okay, alright. It's not the promise we want to cancel, it's the dispatch action we want to cancel. Cool, thank you again. Yeah, will do. I'll bring it on this Saturday if we've got time. Alright. Just thinking out loud, I need a piece of state. I'm just going to write it here. It's not the correct place, but I can move it later. Let's set a board. Right, and we shouldn't abort. Again, this isn't my final solution. I'm just sort of thinking out loud. Why would I need use ref? I'm going to time box this. I'm going to put it to 1/2 and if I don't have it, then I'm just going to watch the solution, because this feels like a problem I could spend the next 3 weeks working on. If that was false, the dispatch wouldn't run, so the promise would resolve as normal. Yeah, so that should be... Gonna stick it in here. Function. This will re-render. Will re-render, but then will that run? Let's grab this. put it in here. Let's pass it back through. Use async. Oh, it's been a while since I've done this. Use async takes an object as its first, and then abort as its second. Callback. Now this all depends on whether this value is stale by the time this dispatches. So add this in here. What I think is going to happen here is this looks good on paper. So if this Pokemon info component unmounts, this use effect return will fire, which will set abort to true, which will trigger a re-render, and we'll pass that. Oh, we'll pass that into here, into this use async. This is true, so this callback will run again. But when this callback is first run, so let's imagine abort is false, as it will be by default. This use async will have this run function. The Pokemon name changes and someone submits it, which will call this run function with abort set to false. Which means it will create a callback, which is a memoized function. Does it store the value of this? And then whenever this resolves itself, is this still going to use the previous value? I think it is. Let's see. Let's play this. Interestingly, the D. Okay. Let's go for it. Yes, I didn't get it that time, which makes me think. Why is that debugger not firing? Okay, so this fires here, right? Should abort. true. Ah, that's why, because nothing resets it back to false. Actually, this remounts. Okay, that's clearly not working. So I'm gonna move this back into the app. And I don't think I'm clever enough to solve this. See ya. Why is a board true? I'm not going to get this. I understand the premise, which is going to be I want to cancel this dispatch rather than canceling the promise. But, I'm going to watch this video as long as it's 6 minutes. See how Ken does it. Okay, that is painfully simple when you know the answer. And of course, I was way off. I'm actually just going to go back in here. I'm going to go to the final. Oh, I can get rid of this. Two extra two. Let's just grab this. Let's go back to where we were. All right, so where's our use async? So we're going to change this, and we're going to make this an unsafe dispatch. We are going to const. We're going to create a ref called mounted ref, which is going to default to false. And then we're going to use an effect. And that effect is going to take whenever this unmounts. Oh wait. This is true by default. Did he set that to true? How did he do it? So we had an effect. We know our component is mounted if this is true. We have an effect that we're going to run, which is going to set this to false. And then we're going to have a dispatch. We're going to have a dispatch function. The dispatch function with mounted ref current equals true. I suppose you can just do that. Let's just be explicit, just because I'm fumbling around at the minute. Alright, so if this is true, then call the unsafe dispatch. Let's just take in all the arguments here, and we'll just pass them straight through. So if this is true, then we can call this. I think that's right. I'm just going to quickly go back. So he's got the effect. Yeah. He needs to reset it to true. Okay. Do I need to? Yeah, that could be empty. Cool. Whenever this is called, this effect will run after render, which means that we know that this is going to be mounted. this dispatch function will be called and we'll pass the arguments through here, and if it is mounted then it will call this. Cool. And then to make it even better, he then lifted everything out. It's a function called use safe dispatch. It takes in a function. Grabbed all of this. Is that a callback? Yeah. Gonna wrap the entire thing in a callback. Just needs dependencies. For some reason my ESLint isn't working. Just return this and call the function. So whenever we call this hook, cool. So I've created a custom hook here. Dispatch is going to pass in the unsafe dispatch. We can guarantee this won't change between renders, so we should be okay to put that in here. If I could spell. So use async is going to be called, and then we have this dispatch variable, which will be a function. So we're going to call this custom hook, and we're going to pass our setter for the reducer into it. That will run. It will create a mounted ref. We'll default it to false. We'll then run the effect, which will set it to true. And whenever it unmounts, we will set it to false. We're going to return a callback function. Yeah, use callback. It's going to pass everything through here. And if mounted ref.current is true, then execute that function. Wow. Okay, let me check it works first. Let's clear that. And if I move to here, mount. That's cool. I really doubt I would have arrived at that solution. This should be fine to include in this callback because dispatch itself is wrapped in a callback. Which will only change. Yeah, okay. So we can include dispatch in this callback because this will run this, which will return this. And this callback will only be run if dispatch changes. And our dispatch in this case is the unsafe dispatch, which is a setter function on this use reducer, which React guarantees won't change between renders. Cool. That was nowhere near my solution, but cool. Feel like I just cheated on a test. I'm just gonna quickly watch this video. Did I break it? I'm just going to quickly watch this video. Cool. All right, let's move on to using context. Right, hopefully I should be a bit better about this. Need to get my ego back. Let's move on. Cool, so this shouldn't work. Let's get rid of that. This shouldn't work, and then, cool. So let's just close that out, and let's open this. create account context here with React create context. So we want to create a count provider component that gets the count state. Create a value array with count. Return your context provided with the value assigned. And more specifically, we need the children prop forwarded to the context provider. Okay, so we have an app. And that app has a count display, which will be this, and we have a counter, which will be this. Count display, the count is set to 0, so this will never change. And then the counter, we have set count, which doesn't do anything. Increment, which takes the current count and adds 1 to it. Never gonna add 1. Cool. So we create a context, and that context has a provider. Oh, I'm tired. And it has a consumer. So the first thing we're going to need to do is get that chili out of my eye. And the second thing we're going to need to do is create a count context. Just null it to begin with. Oh man, that's really in there. Okay, so we've created a context. This is an error or warning and tell us that we're not using it. And then we're going to wrap. Ooh, I think this needs to be capitalized. Yeah. So each context has a consumer and a provider. We have a provider here. Is it value? Is that what you use? Okay. Cool. So we've wrapped everything in this. If the value here was 4, I don't want to jump too far ahead. If one of these is so we have a consumer hook. You can provide a default value, which we'll use in the event someone calls when no value has been provided. So we've set that to null. So we're going to lift the state out of... Don't actually have any state here, do we? Set count, yeah. So we're going to have count, set count. Going to use the state hook. And we're going to set a default value of 0. The value... We can return an object, so we can return the count value and the setter function. So we don't need to, we could pass it through here. But for this example, we're not going to. So we've wrapped this in a provider. So what we need is a consumer in each of these, which will search up the tree for the nearest matching provider, and it will return the value. So let's do the display first. I'm going to set this to 7, just so we'll know if it's actually worked. And I'm going to say const. I'm going to deconstruct that. It's been a while since I've used this. Use context. So I'm going to say this is the same as a provider. So I think, let me just finish this. So here we can get the count here. So the current count is 7 because this is searching up the tree and it's going to find a matching provider and it's going to return the count, which is this default value of 7. That's cool. And I think that is a shorthand way. I'm about to embarrass myself here. I think that is the same as this. So those are provider. Cool. Ah, so it's a function as child. So we would get this. Of course it is. And then the count would be here instead. That's actually returning the entire context. I mean, I suppose I could do it just to keep it similar to what I did before. Do that. Cool. Just to show that's changed, let's change that number. So it's doing the same thing. We've created a consumer which has a function as a child, which will pass the context object that I specify in value through to these components. I've deconstructed this to give me count, and I can return that value. I personally prefer the hook. Let's bring that back. And then let's just double check that's working. Cool. I should be able to do the same thing in here, except this time I want the setter in here. I don't want the count. I do want the count because the increment is going to set the count to the current count plus 1. Cool. Get the set count with the count context. Is that going to give me the current value? No. I wonder if there's a way. Oh, no, of course, because that's not got an actual value in it. The value's stored up here. I'm tired. There we go. Cool. This is more my bag. Your job is to fill in the account provider function components so the app works and the tests pass. Good here. Terminal. Transport hooks. The tests are currently behind my head, so you're just going to have to trust me that they all work. Hey. And for the avoidance of doubt. Hey. Cool. That's 9 o'clock, or just about. So I'm just going to take a 4 or 5 minute break. So I'll be back about 2-3 minutes past 9. Cool. Yeah. Okay. Where were we? Is it this one? You would think I would know these shortcuts by now. Oh man, that light is also far too bright. I'll sort that for next time. Okay, so basic exercise, check. We got this. I guess let's create a consumer hook. So let's imagine what would happen if someone tried to consume your context value without using your context provider. As mentioned above when discussing the default value. If you don't provide a default context value, that would render nothing because it would be undefined. In real world scenarios, yeah, all too familiar with that. And this extra credit, you need to create a custom hook that I can use like this. Okay. And if you change app to this, it should throw an error indicating that use count must be used. Within a count provider. If you change the app to this, that looks like the default. Okay, let's leave that for just now because it will probably contain some sort of handy hint. So we create a function called use count. And in this function, we're going to learn how to actually write a function. Let's just do that. Wait. Oh, it's a function. Oh my goodness, I am tired. Right. This function use count is going to return two things. We're going to return the count, and we're going to return the set. Create a custom hook. I got you. So if you revert it, it should error and say that you need this. Okay, so we're going to keep this up here for just now, I think. And this is going to become use count. Use count. This is going to freak. And this is going to do... This looks a bit repetitive, but I think I know where I'm going with this. So this is going to use context. And it's going to grab the count context and then return it. So this should work just now. Yeah, that's cool, because it's just doing the same thing. The difference being... I could wrap this in an error boundary, but I feel like if you could throw an error... Yeah. Let's make this as crude as you like. Oh, there is wrapped in an error boundary, right? New error. Must be used. Oh, there's no. Cool. Sadly, there's no error boundary. I don't think it's really worthwhile setting that up. I think all we need for this exercise is to show that the error has actually thrown. Cool. So it must be used within it because this is set to true. However, we don't want that. We want... this is null. Which is not spectacular. Let's call this. Let's just call this context. And if context... Actually, let's just see if it's null. Since we've explicitly set it to null here. So if context is null, then throw a new error. Right, so let's refresh this. That shouldn't be null. Let me clear this and just refresh. Apparently it is. Maybe it's because... Tidy this up. Yeah, cool. I think it was just freaking out because these values were undefined. I mean, you could just deconstruct this. I'm really bad at deconstructing, like over deconstructing, if that's such a term. The problem is if this is null, then this is gonna freak. Like if I do this, it's gonna freak. I think it's gonna freak. Yeah, cannot destructure property count of null as it is null. Sounds so condescending. So that's why I don't like destructuring, because now I need to give it a fallback. So if context doesn't exist, give me an empty object of which these will be undefined. The upside of that is I actually get to just return this now. I prefer the first approach, but we'll just keep it like that. Cool, so this should now work. Good times. Caching in a context provider. Let's try the last exercise over again with a bit more of a complex practical example. We're back to the Pokemon info app. This time has caching in place. So if you enter the same Pokemon, it's cached so it loads instantaneously. However, we have a requirement that we want to list all the cached Pokemon in another part of the app. So we're going to use context to store the cache. This way both parts of the app can access it. Because this is hard to describe in words, and because it's a completely separate example, there's a starting point for you. Cool. Thought I was going to have to type that out, which I'm pretty happy with. All right. Create a cache provider function. Use reducer with that. Okay. Start from the top. Let's create a context. Default value of null. Create a Pokemon cache provider function. Use reducer with Pokemon cache reducer and your Pokemon cache service provider. You can grab the one that's in Pokemon info. Return your context provider with the value assigned to what you get back from use reducer. And make sure you forward the props.children. That's quite a lot to take in. Just want to see how similar this is. Cool. So here we have the previous Pokemon. Let's go to here. So we have this component, then we have our normal one. Yep. So we're going to wrap the entire thing, pardon me, in the Pokemon cache context that we created earlier. This is going to be our provider. And the value at this point is going to be nothing. Cool. Let's grab this. Okay, so I shouldn't need this anymore. Get the cache from use context. Okay, so our cache is going to come back here. So this is going to be React use context. This is going to grab the Pokemon cache context. That is not going to work. So we'll set that to an empty object. It should stop it from blowing up. Yeah, because we're going to map over it. All right, so we're going to have probably a cache here. set this to an empty object just now to make sure it doesn't blow up. And let's pass the cache, set cache. And then let's destructure this. So we get the cache from here. Nah. Okay, so we're not actually going to use state here. We're actually going to lift. This is going to be closer to this. And go to dispatch. The initial state will be an empty object here, which we're passing through, which means this won't blow up because an empty object will come over here. And this will become an object. I'm going to use context. I'm going to get rid of this. So we shouldn't need this. We shouldn't need this. This will never change, so it should be okay to add in. Alright, how are we doing here? We've created the context. We've created a provider. Use reducer with Pokemon cache reducer and your Pokemon cache provider. Yeah, that makes sense. Use reducer. We're going to call the Pokemon cache reducer, and we're going to start with an empty object. We can grab the reducer that's in Pokemon info. So let's go to final. Oh wait, we shouldn't. Surely it's in here. Pokemon info. So here's a reducer. Make sure I'm gonna leave that one. Interestingly, he passed that as an array there. Just want to see what this is. Cool. Cool. I mean, it works. That's cool. Make sure you forward the props.children. Make sure you forward the props.children. Why would I need to do that? So this is working, right? We have a use reducer here, which has our cache reducer. which is here. It's going to take state and an action, and if we add a Pokemon, it's going to return the current state, which is spread. And then it's going to pass the Pokemon name through with the Pokemon's respective data. Which will run if this resolves. So it will fetch the Pokemon. If a Pokemon name comes in, it will fetch it, and then it will dispatch from here, which will use context. So the Pokemon info, it's going to search up the tree, and it's going to find this provider and this dispatch, which is going to come from here. I mean, I suppose I can just return the array here, right? This will be broken. That's because that needs to be an array too. It should be good now. Yep. I am going to watch the final video. Actually, before I watch the video, it's the final. We're on exercise 3 extra 2. Cool. Just creating the context. Okay. That's why. Because he's created an actual function for it. Just get rid of that for a bit more space. Let's have a look. So here's the cache provider. Which is here. That's why you need to forward the props to the children. So yeah, we've done the same thing, except I've actually just declared it in the actual section. This should do the same thing. Cool. Nice. I suppose that's a nice separation. Nice, that just keeps everything contained within here rather than diluting the actual section with the provider. Cool. Pretty straightforward so far. And I now understand what this is. Cool. I'm just going to quickly watch these videos. should be like 5 minutes. All right, that one's a bit longer, so I'm going to watch the final one in my own time. Let's move on to use layout effect. Cool. Let's use layout effect. Let's get rid of this. Okay, so we should add message. There's no exercise for this one because you basically need to replace use effect with use layout effect. You're good. Excellent. So you pretty much just need to experiment with that. Before you do that, compare the finished example with the exercise. Add remove messages, and you'll see there's a janky experience with the exercise version. If you are making observable changes to the DOM, then it should happen in use layout effect. Otherwise, we should use effect. Cool. So let's look at the final one. Yeah, that's cool. Yeah, I've run into this issue a couple of times where we ended up having to use layout effect. So use layout effect, pretty sure, we'll put this up, but I'm pretty sure the main difference between the two of them is use effect runs after the render cycle and use layout effect runs before it. So the reason that this one isn't janky is because this is manipulating data and it's doing so and then rendering, which is why you don't get the jank. Whereas in this one, yeah, that's going to run after the render cycle, which is going to scroll to the bottom and then re-render, add another one, and cause the jank. Yeah. This is to simulate major computation. Slew sibling. Okay. Maybe I've got that wrong. Your code runs immediately after the DOM has been updated, but before the browser paints it. Whereas this runs post-paint, I think, right? Runs it after it renders your component. Yeah. So if I add a message, is that what the sleep thing's going to do? It's going to emulate it. Try this with use layout effect as well. Repo. Ah, it's because I've added them all. Okay, add message. Okay, let's put that to 500. So we're going to add message here. We're just going to set messages. So I'm going to grab them. And then we're going to pass this in. The messages will update. So the new message will be added in. The browser will paint. And then this effect will run, which will then scroll it to the bottom. Whereas what we actually want to do is this. Because in doing so, it'll do it before it paints this. So the DOM mutations will happen. The new messages will come through. It will be mutated on the DOM, but the user won't be able to see the changes. This will run first, and it will scroll to the bottom of this, and then it will paint the changes. Nice. Oh, that was nice and easy. Do I have time for that? Yeah, I get 20 minutes. I should have time to get this one as well. This video's 2 minutes long. This looks a bit more involved. So we're going to use imperative handle. Function components cannot be given refs. That's cool. So it's bugged out as it begins. This isn't going to work. This doesn't work. This does. This does this. All right. Let's have a look at the final. So we should be able to scroll to top, scroll to bottom. That's cool. And then these should both work. Yeah. All right. So it's clear. Oh, actually, that error message is probably going to be quite handy. So they can't be given refs. Let's open the new exercise. Wrap this in a React forward ref and accept ref as the second argument. This entire thing is a function. It's been a while. So it's normally a function, but we're going to pass that as the second argument. Cool. Okay, so that... how do I wrap the function? I'm just gonna do this the way I know. Turn this into an anonymous function. Like so. And then I'm gonna wrap that in the forward ref. That is going to take messages as the first argument and ref as the second. And this should close it up. Okay, so that should be fine. Use layout effect, scroll to bottom. You're going to want this as part of your imperative methods. Function scroll top. Okay, I'll leave that for now. Call use imperative handle here with your ref and a callback function that returns an object with scroll to top and scroll to bottom. I have never used this before. Okay, what does this do? In 13 minutes. It customizes the instance value that is exposed to parent components when using ref. As always, imperative code using ref should be avoided. Okay, so use imperative handle. That takes a ref, which will be passed in from messages.display or messages display. And then we're going to give it a callback function, which is going to return an object, which is going to have scroll to, don't know why scroll to top needs to be first, but it just does. I don't know why that's commented out. Like, do I need to define it in there? Dunno. Okay, so when we add class components, we could do stuff like this. We would create the ref and focus input would focus this. Yep. Ref equals this dot my input ref, which is here. Cool. Yeah. So that would give us access to this here, which means we could focus the input. With function components, there's no component instance, so this won't work. You just declare it. Yeah. Cool. We have a function here of my input. It takes props and ref. We forward the ref through. The input ref, we set the current value to be an object with imperative methods. And we return it. So we forward the ref as before. We're going to use the imperative handle. That's going to take the ref that is passed in here. And it's going to return a callback function. And it's going to take a callback function, which returns an object of imperative methods. And those methods can access the component, well, not the instance, but it can access the ref. That's cool. So you can pass a ref and then they'll get access to that. So they pass their own ref. And then they gain access to those methods. Cool. So we're going to use the imperative handle. We're going to take the ref that's passed in, return these functions. And those functions have access to this container ref. What's the name of this component? So we have this messages display component. So if we pass in our own ref, which is going to be here, that's going to give us access to those imperative methods. I have never used that. Does it work? Yeah, it does. That's cool. Can't think of a time I'd actually need to use it, but it's good to know that I can use it. So we pass the ref in. I suppose what I would normally do is just lift. I suppose that keeps it contained to here. Interesting approach. I think I would personally just lift this out. And then, how would I make that more declarative? Maybe just make it like on change, or so we have this scroll to top function. So target this ref. You need access to the actual container. I think I'm going to play around with that and try and put that into a more declarative style. It's basically a nice way to expose this. Strange that we're learning something that we're never really going to have to use. I suppose it's handy to have in the edge case that you actually need to implement something like this. I suppose you could. I wonder if the exercises are going to follow onto this, because you could use context, right? You could actually lift these methods out into a context provider. I wonder if you could store the ref in context, and then when you click this, it would use the provider, and then actually scroll it. That's how you would do it, yeah. So you would wrap this entire thing in a context provider, and you would store the ref and the methods. Would you need the methods? You would definitely store the ref in the context provider. Because then we could attach it here. We could use like const, and then let's say we destructured it, and then got the container ref here. Use context. Use context here. What's context? That gives us access to this in here. And then we would const container ref equals use ref, and then we would have a provider in here where the value is equal to the ref, and then anyone would be able to access this. And that's how you would do it. Nice. Anyway, that's my timeout. That's not actually part of the exercise. I'm thinking that's going to be the next exercise, is putting those last three exercises together. Let me just put that back to a working condition. Cool. Learned a bunch tonight, actually. There we go. That should be us back to a working version. Scroll to top, scroll to bottom. Yeah, nice. Yeah, learned an absolute bunch tonight. Learned, what do we finish off? We finished off the custom hook, although we cheated. But there was absolutely no way I was going to get it. We started using context, both providers and consumers. We used the hook consumer as well as the component version. We learned about use layout effect and its differences with use effect. And we learned about the use imperative handle hook that I'm never going to use in my entire life. So that's cool. But that is time for tonight. And I will be back on Thursday, 8 o'clock. And then we can move on to use debug value and see what's going on. But I'm going to bed because I'm absolutely knackered. So I will see you all on Thursday.